Hello, good morning everyone. It's me again, Sir A, and welcome back to my virtual class. So last time we talked about elements and compounds, though napahapyawan natin ang mixture. So what again is a mixture? Okay, so based on our last topic, last video discussion, a mixture contains two or more elements or compounds that are not chemically combined. Again, they are not chemically combined. And under mixtures, we have two categories. We have the heterogeneous mixtures and the homogeneous mixture. So what is a homogeneous mixture? When we say homogeneous mixture, it is a mixture in which composition is uniform throughout the mixture. Yes, it is the total opposite of heterogeneous mixture. A heterogeneous mixture, the composition of it is not uniform throughout the mixture. You can observe it by my examples. So examples of homogeneous mixtures are, we have the vinegar, we have the honey, we have the coffee, we have blood, and we have the perfume. So in those examples, you cannot see its individual components or ingredients. You can see it as one. Iisa lang yung itsura niya. Unlike sa heterogeneous mixtures, we have the chocolate chip, we have the pizza, we have the salad, and of course, our very own halo-halo. Or even kapag nagluluto si nanay, ng pinakbet, no? Halo-halo yung gulay na yan. And kadalasan na ginagawa ninyo, iniihiwalay ninyo ang ampalaya from the rest. So, you are able to separate ampalaya from pinakbet. So, that is the difference between heterogeneous mixture and homogeneous mixtures. But again, ulitin ko, they are not chemically combined. Before we go on, I would like to talk about solution. So, what is a solution? When we say solution class, it is a homogeneous mixture of one or more solutes dissolved in a solvent. Sir, ano po ba ang solute at ano po ba ang solvent? So when we say solvent, it is the substance in which a solute dissolves to produce a homogeneous mixture. And when we say solute, it is the substance that dissolves in a solvent to produce homogeneous mixture. So, sa madaling salita, mas madami yung solvent kaysa sa solute. Kadalasan, yung solute, siya yung mas konti. Siya yung natutunaw. Siya yung nawawala. Siya yung naihahalo. Yung solvent, siya yung mas madami. But not all the time. We have the water. Tinawag siya na universal solvent. Why? Kahit na siya ang mas konti, na sinabi ko kanina, kapag konti siya ang solute, kapag solvent siya yung madami, unlike sa water, kapag kahit siya yung konti, siya pa rin ang tatawagin nating solvent. Why? Water, it is the universal solvent. No? And under heterogeneous mixtures, we have the suspension. So, what is a suspension? When we say suspension, it is cloudy and heterogeneous. The particles are larger than 10,000 angstrom, which allows them to be filtered. So again, yung mga particles doon sa suspension, naka-scattered throughout the substance yan. So yung angstrom, it is a unit, no? Unit ng size sa substance na yan. So kapag 10,000 angstroms, pwede na siyang i-filter. So, if a suspension is allowed to stand, the particles will separate out or maybe magsisettle down. Actually, that is the process of decantation na i-discuss natin later on. So, for example, this one. Kapag nilagyan ko to ng sand and then kapag hinalo ko, makikita natin yung sand na mag-i-scatter siya sa tubig. Pero if I'm going to let it stand like this one, at hindi natin siya i-disturb, magsisettle down yung sand. So, yun yung decantation na gagawin natin later on. How about colloid? No? How about colloid? Sana hindi kayo malito regarding suspension and colloid. So when we say colloid class, they are special type of mixture where tiny particles of substance are scattered through another substance. Sir, parehas naman pong naka-scatter si colloid at saka si suspension. Yes, parehas na naka-scatter yung mga particles doon sa colloid and suspension. Yun nga lang, si suspension kasi, magsisettle down yung mga particles niya, unlike kay colloid. And colloid, it is a intermediate between a solution and a suspension. While suspension will separate out, gaya na sinabi ko kanina, colloid will not. Colloids can be distinguished from solutions using the Tyndall effect. When we say Tyndall effect, magdi-disperse yung light kapag dinaanan ito ng light. No? For example, this one, kapag may dumaan na light sa kanya, magdi-disperse yung light. That is the Tyndall effect. So before we move on, I would like you to look at this table. For the preparation of our next topic, which are the separation technique, I would like you to watch this short video clip.
A solution is a mixture of two or more substances in the same phase. This is formed when a solute dissolves in a solvent. A solution can also be formed when two or more miscible liquids are mixed together. When ethanol and water are mixed together, a solution is formed. Now, how would we separate these solutions? To separate dissolved salt from water, we would simply evaporate as much water as possible, leaving behind white salt crystals. The separation technique is known as evaporation. To separate ethanol from water, we must take into account the fact that these substances have very different boiling points. Water boils at 100 degrees Celsius, whereas ethanol boils at 78 degrees Celsius. This mixture can be separated by simple distillation. The lower boiling point component, in our case ethanol, will evaporate first. The ethanol vapor condenses as it passes through the condenser, and the distilled ethanol can then be collected in the receiving flask. The above mixtures are homogeneous mixtures. This means that the components of the mixture are in the same phase, or the composition of the mixture is uniform throughout. Now, we will look at separating heterogeneous mixtures, where the components in the mixture are not in the same phase, or the composition of the mixture is uneven. If we have a mixture of sulfur and iron filings, we can easily separate this mixture with a magnet. The magnet will remove all of the iron filings, leaving behind the yellow sulfur powder. We know that salt is completely soluble in water, but sand is not. How would you separate a mixture of salt and sand easily, keeping in mind the solubility of salt in water? Pause, think, and continue when you have an answer. The salt and sand mixture can be added to water. Salt will dissolve, but sand cannot. The resulting heterogeneous mixture can be filtered through a funnel lined with filter paper and washed with water to remove as much salt as possible. The substance that remains on the filter paper is known as the residue, and the substance collected in the flask is called the filtrate. For our case, sand is the residue, and the salt water is the filtrate. The salt can be obtained using evaporation and the sand left to dry. The same method is used to separate a suspension, which is a mixture of an insoluble solid in a liquid, such as, for example, small bits of chalk in water. Two immiscible liquids, such as oil and water, can be separated using a separatory funnel. This is an apparatus with a stopcock at the bottom. Releasing the stopcock allows the contents to flow out, and closing it stops the flow. To summarize, there are many different techniques to separate mixtures, all depending on whether the mixture is homogeneous or heterogeneous.